Welcome! In this session, we will introduce random forest, a machine learning algorithm. What is random forest? Random forest is a supervised learning algorithm. The forest it builds is an ensemble of decision trees, usually trained with the bagging method. Random forest is a flexible, easy-to-use machine learning algorithm that produces, even without hyperparameter tuning, a great result most of the time. It is also one of the most used algorithms because of its simplicity and diversity, as it can be used for both classification and regression tasks. How random forests work? Random forest uses the bagging or ensemble method, a technique that combines the predictions from multiple machine learning algorithms together to make more accurate predictions than any individual model. The general idea of the bagging method is that a combination of learning models increases the overall result. If you want to put it simple, random forest builds multiple decision trees and merges them together to get a more accurate and stable prediction. One big advantage of random forest is that it can be used for both classification and regression problems, which form the majority of current machine learning systems. In this course, we will look at random forest in classification, since classification is sometimes considered the building block of machine learning. In the current slide, you can see how a random forest will do like with two trees. Random forest has nearly the same hyperparameters as a decision tree combined with a bagging classifier. Random forest adds additional randomness to the model while growing the trees. Instead of searching for the most important feature while splitting a node, it searches for the best feature among a random subset of features. This results in a wide diversity that generally results in a better model. Therefore, in random forest, only a random subset of the features is taken into consideration by the algorithm for splitting a node. While random forest is a collection of decision trees, there are some differences. If you input a training dataset with features and labels into a decision tree, it will formulate some set of rules which will be used to make the predictions. For example, to predict whether a person will click on an online advertisement, you might collect the ads the person clicked on in the past and some features that describe his or her decision. If you put the features and labels into a decision tree, it will generate some rules that help predict whether the advertisement will be clicked or not. In comparison, the random forest algorithm randomly selects observations and features to build several decision trees and then averages the results. Another difference is deep decision trees might suffer from overfitting. Most of the time, random forests prevent this by creating random subsets of the features and building smaller trees using those subsets. Afterwards, it combines the subtrees. It's important to note this doesn't work every time, and it also makes the computation slower depending on how many trees the random forest builds. There are two important parameters in the random forest algorithm. On the one hand, importance is a measure of how much removing a variable decreases the precision and vice versa, how much the precision increases when including a variable. On the other hand, proximity means the closeness or nearness between pairs of cases. Proximities are calculated for each pair of case observation sample points. If two cases occupy the same terminal node through one tree, their proximity is increased by 1. At the end of the run of all trees, the proximities are normalized by dividing by the number of trees. Proximities are used in replacing missing data, locating outliers, and producing illuminating low-dimensional views of the data. And finally, let's talk about the advantages and disadvantages of random forest. On the side of the advantages, one of the biggest ones of random forest is its versatility. It can be used for both regressions and classification tasks, and it's also easy to view the relative importance it assigns to the input features. Random forest is also a very handy algorithm because the default hyperparameters it uses often produce a good prediction result. Understanding the hyperparameters is pretty straightforward, and there is also not that many of them. One of the biggest problems in machine learning is overfitting, but most of the time this won't happen thanks to the random forest classifier. If there are enough trees in the forest, the classifier won't overfit the model. On the side of the limitations, the main limitation of random forest is that a large number of trees can make the algorithm too slow and ineffective for real-time predictions. In general, these algorithms are fast to train, but quite slow to create predictions once they are trained. A more accurate predictions require more trees, which results in a slower model. In most real-world applications, the random forest algorithm is fast enough, but there can certainly be situations where runtime performance is important, and other approaches would be preferred. And of course, random forest is a predicting modeling tool and not a descriptive tool, meaning if you are looking for a description of the relationship in your data, other approaches would be better. In the next session, we will illustrate the use of random forest in R. Thanks for watching.